07:42 a.m., 15th April 1945, over New Guinea. The sound of propellers slices through the humid air, a constant whine, stretching and pulling on every nerve, a glint of silver as the P-51 Mustang banks, sharply, the sun catching its wings like a predator's eyes. In the cockpit, Hans Richter, a German test pilot, clenches the controls, eyes fixed on the unfamiliar dials before him. The radio crackles, distant voices, commands lost in the static. His mind races. Only 30 minutes. 30 minutes to prove that the P-51 Mustang, America's new weapon, could be tamed. The task? Test its limits, find its weakness. But the moment he pushes the throttle forward, the Mustang responds with a grace he's never felt in his Luftwaffe training. Out of nowhere, a fast-moving formation of Allied fighters crosses the sky. A wave of adrenaline. His pulse quickens. The P-51 doesn't follow orders. It anticipates them. And that's when it hits him. This was not just another fighter. The morning of 15th April 1945 arrives cold over Bavaria. Hans Richter steps from the hangar into dawnlight that cuts sharp across the concrete apron. His flight suit pulls tight across his shoulders, boots echo against the tarmac as he approaches the waiting aircraft. The P-51D Mustang sits isolated on the hardstand, silver skin gleaming under arc lights. Captured 3 weeks prior during a forced landing near Regensburg, the fighter now rests under Luftwaffe guard. Ground crew moves around its frame with cautious efficiency, their tools clicking against unfamiliar components. General Vogel approaches, clipboard in hand. The fabric of his uniform rustles in the pre-dawn wind. The orders are simple, Richter. Evaluate, test, determine weaknesses. Your 30 minutes start at 0800 hours. Hans accepts the clipboard. The weight feels substantial. He has logged nearly 2,000 hours in Messerschmitt Bf-109s, but the Mustang represents something different. Its wingspan stretches 11 meters. The Packard-built Merlin engine produces 1,400 horsepower. The numbers alone demand respect. Around him, mechanics adjust fuel lines and check hydraulic pressure. Their movements are efficient, but uncertain. No German maintenance manual exists for this aircraft. They work from observation and intuition. Hans studies the Mustang's profile. The laminar flow wing design reduces drag. The bubble canopy offers 360 degrees of visibility. American engineering philosophy made visible. Range, speed, visibility. Nothing wasted. He moves toward the cockpit. The aluminum skin feels cold under his gloved hand. He unlatches the canopy and climbs onto the wing root, then settles into the seat. The cockpit surrounds him, tighter than the Bf-109, more instruments clustered across the panel. His fingers trace the control stick. Solid construction, precise movement. The throttle quadrant sits to his left. Friction locked. He adjusts the rudder pedals, checks the gun sight, alignment, scans the fuel quantity indicators. The radio operator's voice filters through his headset. Mustang test aircraft, you are cleared for engine start at your discretion. Hans nods to himself. He primes the fuel system, sets mixture to rich, advances the throttle 1 inch. The starter engagement sounds different from German equipment. A higher whine, faster cranking speed. The Merlin catches on the third blade rotation. Blue exhaust smoke drifts past the canopy. The engine note settles into a deep, smooth idle. 1200 RPM. Oil pressure climbs into the green arc. Coolant temperature begins its slow rise. Hans completes the checklist from memory, cross-checking against the unfamiliar instrument layout. At 0758, he signals ready. The tower clears him for immediate takeoff. Hans releases the parking brake, advances the throttle smoothly, and feels the Mustang surge forward. By 0800 hours, Hans is climbing through 3,000 feet over the Bavarian hills. The Mustang accelerates with minimal control input. He trims for level flight at 250 miles per hour. The controls respond with precision. He has not experienced in German fighters. The instrument panel reflects morning light, airspeed indicator, altimeter, artificial horizon, all American calibrated but readable. He notes the manifold pressure gauge, the cylinder head temperature readouts, the fuel flow meter. Each instrument provides data with clarity. Hans banks the Mustang into a gentle turn. The ailerons require less force than he anticipated. Roll rate exceeds his expectation. He reverses the turn, checking coordination. The aircraft tracks smoothly through the air, no adverse yaw, no tendency to overbank. He climbs to 6,000 feet and initiates a series of stalls. Power off stall occurs at 92 miles per hour with clean configuration. The Mustang settles into the stall with gentle buffet, no wing drop. Recovery requires minimal altitude loss. He repeats the test with gear and flaps extended. Again, the aircraft demonstrates benign handling. Hans pushes the throttle forward to 45 inches of manifold pressure. The Merlin responds with smooth acceleration. Airspeed builds rapidly, 280, 300, 320 miles per hour. The controls remain effective. No flutter, no vibration. He rolls inverted and pulls through to complete a loop. G-forces press him into the seat. The Mustang maintains energy throughout the maneuver. At the apex, airspeed reads 140 miles per hour. Sufficient margin. Below, the landscape scrolls past. Forests, villages, agricultural fields rendered in miniature. Hans references his map, confirms his position relative to the test area boundaries. 15 minutes elapsed, 15 remaining. He deploys the landing gear. 3 green lights confirm down and locked. The airspeed penalty is noticeable but not severe. He cycles the gear twice more, timing, the extension and retraction. Hydraulic system operates without hesitation. Radio check at 0815. Test pilot reports aircraft handling exceeds specifications, continuing evaluation. Hans maneuvers toward the Alpine foothills. The terrain rises beneath him. He descends to 4,000 feet, maintaining visual reference with the ground. The Mustang cuts through turbulence with minimal disruption. Stability augmentation is unnecessary. The airframe design provides inherent damping. He considers the strategic implications. This aircraft can escort bombers to Berlin and return. Its range exceeds 1,000 miles with external tanks. German fighters cannot match this endurance. The tactical advantage is overwhelming, but understanding comes with a cost. Each minute in this cockpit reveals how far American industrial capacity has progressed. At 0830, Hans guides the Mustang toward the Alps. The peaks rise ahead, snow-covered summits touching 10,000 feet. He climbs to match the terrain, watching the altimeter needle sweep clockwise. The engine note changes, a subtle misfire, barely perceptible but present. Hans scans the instrument panel. Manifold pressure fluctuates. The tachometer needle wavers. He reduces power slightly, enriches the mixture. The rough running persists. His hands tighten on the control stick. Not now, not here. He cycles the fuel selector, checking both main tanks. Fuel quantity remains adequate, no indication of contamination or vapor lock. The misfire continues, an irregular rhythm in the Merlin's otherwise smooth operation. Hans considers his options. Abort the test and return to base. Continue the evaluation despite the anomaly. Report the condition and request guidance. The decision tree branches before him. The radio crackles. Test pilot, report status. Experiencing intermittent engine roughness. Manifold pressure unstable. Continuing evaluation at reduced power setting. A pause. Then, understood, monitor closely. Return if condition worsens. Hans throttles back to 38 inches manifold pressure. The misfire decreases in frequency but does not disappear. He maintains altitude, adjusting trim to compensate for the reduced thrust. The Alps fill his forward view. Vertical rock faces, glacial valleys, isolated peaks. Beautiful and indifferent. Engine failure here means forced landing in terrain that offers no forgiving options. He notes the time. 8 minutes remaining in the test window. 8 minutes to extract maximum information from an aircraft that now operates with compromised reliability. The Mustang handles the reduced power smoothly. Control response remains crisp. Hans executes a series of turns, climbs, and descents. The airframe performs without complaint. Only the engine betrays uncertainty. He descends to 6,000 feet, moving away from the highest terrain. Safety margin increases. The misfire continues its irregular pattern. 3 smooth seconds, 1 rough, 2 smooth, 1 rough. A rhythm he cannot predict or control. Hans thinks about the mechanics at the test facility. They have worked with this aircraft for 3 weeks, learning its systems through reverse engineering. No technical orders, no maintenance manuals, just observation and deduction. The clock advances, 7 minutes remaining. He turns the Mustang back toward Bavaria, maintaining heading and altitude. The engine misfire persists, a reminder that even superior design cannot overcome inadequate maintenance procedures. Records later showed this Mustang had received contaminated fuel during its previous Allied operation. The German ground crew lacked the filtration equipment to detect the impurity. At 0840, Hans pushes the Mustang higher despite the engine irregularity. 9,000 feet. The air thins. Temperature drops. His breath fogs the canopy edge. He initiates a high-speed dive, monitoring airspeed as it accelerates past 350 miles per hour. The Mustang remains stable, no control stiffening, no structural vibration. At 400 miles per hour he begins a gentle pull-up. G-forces build gradually. The airframe absorbs the stress without complaint. The engine misfire continues. Hans notes the pattern in his mental log. Power loss occurs approximately every 7 seconds. Duration 1 to 2 seconds. Magnitude roughly 10% reduction in manifold pressure. Manageable, but concerning. He levels at 10,000 feet. Oxygen would be advisable at this altitude during sustained operations. The test profile does not include oxygen equipment evaluation. Hans breathes normally, accepting the slight hypoxic effect. The controls feel precise, more responsive than the Bf-109 at equivalent speed. The Mustang's control harmony, the balance between aileron, elevator and rudder forces, demonstrates sophisticated design philosophy. American engineers understood the importance of pilot workload reduction. Hans rolls the aircraft through 360 degrees. The rotation is smooth, predictable. He reverses and rolls the opposite direction. Again, the Mustang performs flawlessly. Only the engine disturbs the perfection. Below, the Bavarian landscape spreads in morning light. Villages emit thin smoke trails. Roads trace geometric patterns between fields. A train moves south, its white steam plume marking progress. Hans considers what this aircraft represents. Not merely a weapons platform, an industrial achievement. Thousands of man-hours crystallized into aluminum, steel, and plexiglass. American production capacity made tangible. The radio interrupts. Test pilot, 4 minutes remaining. Acknowledged, preparing for return. Hans banks the Mustang toward the test facility. Distance, approximately 30 kilometers. Time required, 6 minutes at current airspeed. He calculates the timeline. landing, shutdown, debriefing. The schedule remains tight. The engine misfire suddenly increases in frequency. Manifold pressure drops 15 inches. The Mustang decelerates. Hans enriches the mixture, adjusts the propeller pitch. Power partially recovers but remains unstable. He descends to 8,000 feet, trading altitude for airspeed margin. The aircraft responds normally to control inputs, but the engine now misfires every 3 seconds. Consistency in the degradation, if nothing else. Hans maintains his heading. 3 minutes to the facility. The Mustang continues flying, its airframe reliable even as its power plant falters. In the cockpit, surrounded by American instruments and German uncertainty, Hans Richter flies on. At the test facility, mechanics gather around the telemetry console. Radio transmissions from Hans filter through the speaker, his voice calm, but the situation clear. Engine malfunction, deteriorating performance. Carl Schneider, a 23-year-old mechanic, studies the fuel system diagrams spread across the workbench. He has spent 14 days mapping the Mustang's fuel delivery system. Pumps, filters, lines, valves, each component different from German equipment. His supervisor approaches. Can we isolate the problem? Fuel contamination, most likely, Carl replies, but without direct access, we cannot confirm. The telemetry console displays engine parameters transmitted from the Mustang. Manifold pressure, fluctuating. RPM, unstable. Cylinder head temperature, within limits. Oil pressure, normal. The data suggests fuel delivery issues rather than mechanical failure. Another mechanic, older, with grease-stained hands, speaks. If the fuel filter is clogged, he needs to switch to the auxiliary pump. Carl shakes his head. The P-51's fuel system design differs from ours. The auxiliary pump may not provide sufficient flow at altitude. They watch the telemetry update. Altitude decreasing, airspeed steady. Hans is managing the situation, but the margin narrows. The supervisor makes a decision. Prepare the emergency equipment. If he cannot reach the runway, we need crash response ready. Teams move into position. Fire trucks start their engines. Medical personnel gather equipment. The routine practice, but never welcomed. Carl returns to the fuel system diagrams. His mind works through the problem. Contamination in the main tank. Particles too small for visual detection, but sufficient to restrict flow through the carburetor jets. The Merlin engine requires precise fuel metering. Any disruption affects performance. He considers solutions. Fuel system purging. Filter replacement, tank inspection, all necessary. But first, Hans must land the aircraft intact. The radio crackles. Test pilot 2 minutes from pattern entry. Request priority landing clearance. The tower responds immediately. Clear to land any runway. Emergency equipment standing by. Carl watches the telemetry screen. Engine power continues deteriorating. Manifold pressure now reads 32 inches, barely sufficient for level flight. Hans will have one. Landing attempt. No missed approach capability. No margin for error. The mechanics stand silent, watching instruments display data from an aircraft they understand only partially, flown by a pilot executing a test that has exceeded its parameters. Outside, the morning sun climbs higher. Inside the maintenance facility, men wait for an outcome they cannot control. The telemetry updates. Altitude 1,500 feet, descending. At 0855, Hans crosses the airfield boundary at 800 feet. The Mustang's engine runs rough, power output reduced to approximately 70%. He maintains 95 miles per hour, balancing between stall speed and excess airspeed that would complicate the landing. His hands are steady on the controls. Sweat dampens his collar despite the cold at altitude. The runway stretches ahead. 2,400 meters of concrete painted with German markings. Adequate length, but the Mustang's landing characteristics remain unknown to him. He lowers the landing gear. 3 green lights confirm down and locked. The airspeed penalty costs him 15 miles per hour. The engine stumbles, recovers, stumbles again. Hans advances the mixture control fully rich, extracts maximum power from the failing engine. 500 feet altitude. The Mustang descends at 300 feet per minute. Hans deploys half flaps. The nose pitches down. He compensates with back pressure on the stick. Airspeed decreases to 85 miles per hour. The ground rises to meet him. Details emerge. Individual concrete slabs, painted distance markers, tire marks from previous landings. Hans references the runway centerline, makes small corrections with rudder and aileron. 300 feet. The engine misfire becomes continuous now. Power fluctuates randomly. Hans ignores it, focuses on the landing site picture. Airspeed 80 miles per hour, descent rate controlled, alignment centered, 100 feet. He begins the flare, gradually reducing descent rate while managing the energy state. The Mustang settles toward the runway. 50 feet, 20 feet. The main wheels contact concrete with a firm chirp. Hans pulls the throttle to idle and deploys full flaps. The nose wheel settles. He applies brakes smoothly, avoiding skidding. The Mustang decelerates, tracking straight down the runway centerline. At 40 miles per hour, the engine coughs twice and dies. Complete power loss. But Hans has landing speed under control. The Mustang rolls to a stop 1,200 meters from the threshold. He sits motionless for 3 seconds, breathing deeply. His hands release the controls. The cockpit falls silent. No engine noise, no radio chatter, just the sound of wind over the canopy. Emergency vehicles approach, their sirens cutting through the morning air. Hans unstraps, opens the canopy, and climbs out onto the wing. His legs feel unsteady after the adrenaline surge. General Vogel's staff car arrives. The test, despite its complications, is complete. The Mustang sits silent on the runway, its secrets partially revealed. Hans stands beside the Mustang as mechanics swarm the aircraft. They open access panels, inspect fuel lines, probe the engine compartments. Carl Schneider appears with a sample jar, drawing fuel from the main tank. The liquid appears clear, but he seals the container for laboratory analysis. General Vogel approaches, his expression unreadable. "Your report, Richter?" Hans chooses his words carefully. "The aircraft handling exceeds any fighter I have flown. Control response is precise. Visibility is superior. Range capability appears substantial based on fuel consumption estimates. And the engine failure? Fuel contamination most likely, not a design flaw. The airframe performance remains impressive despite the power plant issue." Vogel nods. "We will inspect the fuel system thoroughly. Your written assessment is required by 1400 hours." "Understood, Herr General." Vogel pauses, then speaks more quietly. "Your honest evaluation, Richter, as a pilot, how does it compare to our fighters?" Hans glances at the Mustang. Its silver skin reflects morning light. The bubble canopy, the laminar flow wings, the streamlined fuselage, every line purpose-built for a specific mission. Long-range escort at high altitude. "It represents a different philosophy," Hans says. "We designed the Bf-109 for short-range interception, climb rate, maneuverability, firepower. The Mustang sacrifices none of these but adds strategic range. It can escort bombers to any target in Europe and return home. Superiority, then? In its intended role, yes, absolutely." The admission hangs in the cold air. Vogel's face tightens, but he nods once. "Include that in your report." He returns to his staff car. Hans watches him depart, then turns back to the Mustang. Mechanics work around its engine, their tools creating metallic percussion. Carl emerges from beneath the cowling, his hands black with oil. The fuel filter is completely clogged, Carl reports. Particulate contamination throughout the system. We can clean it, but the damage may already extend to the carburetor. Can you make it airworthy again? Given proper equipment and time, yes, but we lack American specifications for tolerances and settings. Hans nods. Do what you can. He walks toward the debriefing room, his flight suit still damp with sweat. Behind him, the P-51 Mustang undergoes dissection, its secrets extracted by men who understand they are studying technology that has already shifted the balance of air power. In the hangar, sunlight cuts through windows, illuminating dust particles suspended in still air. By 0930, Hans sits at a desk in the debriefing room, paper and pen before him. The report format is standard: aircraft identification, mission parameters, observed performance, recommendations. But the content resists simple categorization. He begins with technical specifications: wingspan 37 feet, length 32 feet, maximum speed approximately 430 miles per hour based on dive performance, service ceiling estimated above 40,000 feet, range in excess of 1,000 miles with external fuel tanks. The numbers accumulate on paper. Each figure represents American industrial capability. The Packard Motor Company producing Rolls-Royce Merlin engines under license. North American Aviation assembling airframes at rates German factories cannot match. Strategic depth translated into tactical advantage. Hans describes the handling characteristics. Control harmony excellent. Roll rate superior to Bf 109 at speeds above 250 miles per hour. Stall behavior benign. Visibility from cockpit exceptional due to bubble canopy design. Pilot workload reduced through ergonomic instrument layout. He notes the fuel system malfunction, but emphasizes that it likely resulted from contamination during capture, not design deficiency. The Merlin engine, when operating properly, delivers smooth power throughout the envelope. Throttle response is immediate, no tendency toward overheating observed. Range capability presents the greatest concern. Hans calculates fuel consumption based on observed burn rates. The Mustang carries internal fuel, sufficient for approximately 2 hours of combat operations. With external drop tanks, which the captured aircraft lacks, range extends to 4 or 5 hours. This enables escort missions deep into German territory. He writes, "The P-51D Mustang represents a fundamental shift in fighter doctrine. Previous Allied fighters could not escort bombers to distant targets. The Mustang eliminates this limitation. Our interception strategy, which relied on attacking unescorted bombers, now faces obsolescence. The admission is clinical, factual, but its implications are strategic. Every Mustang in Allied service extends bomber survivability. Every bomber that reaches its target damages German industrial capacity. The mathematics of attrition work against the Luftwaffe." Hans continues writing. He documents the test flight chronologically. Takeoff at 0800, initial handling evaluation, high altitude performance assessment, engine malfunction onset, emergency return and landing. Total flight time, 55 minutes. At the bottom of page 3 he provides his final assessment. The P-51D Mustang is superior to current Luftwaffe fighters in range, high altitude performance, and pilot visibility. Recommendation: prioritize development of long-range German escorts or reconsider daylight interception tactics. He signs the document, dates it 15th April 1945, and places it in the outgoing folder. Outside, mechanics continue working on the Mustang, chasing answers the report cannot provide. In the hangar, afternoon light angles through high windows. Carl Schneider disassembles the Mustang's fuel system, component by component. The fuel filter lies on a white cloth, its element clogged with brown particulate. He photographs it from multiple angles, documents the contamination level, bags the filter for laboratory analysis. The carburetor reveals similar contamination. Residue coats the jets, restricting fuel flow. Carl carefully cleans each passage using solvents and compressed air. The work is meticulous, time-consuming. Each component must be restored to specification without access to those specifications. Another mechanic inspects the fuel tanks. He inserts a borescope, examining internal surfaces for corrosion or debris. The tanks appear intact, but show signs of inadequate pre-flight servicing. The Allied crew that flew this Mustang before its capture likely faced fuel quality issues as well. Carl reassembles the carburetor, torquing each fastener to estimated specification. He installs a replacement fuel filter, a German component modified to fit the American system. The adaptation is imperfect but functional. Without proper parts, improvisation becomes necessity. By 1500 hours, the fuel system is reassembled. Carl performs a ground run. The Merlin engine starts smoothly. He advances the throttle incrementally, watching instruments. Manifold pressure climbs steadily. No misfiring. Fuel flow remains constant. Temperature and pressure parameters stay within normal ranges. He shuts down after 5 minutes. The engine has responded well to the repairs, but ground testing cannot replicate flight conditions. Only another test flight will confirm whether the problem is solved. General Vogel observes from across the hangar. He approaches Carl as the engine noise fades. "Your assessment?" "The contamination is cleared, Herr General. The engine should perform normally now, but I recommend a brief test flight before any extended evaluation. Richter will fly again tomorrow morning. Prepare the aircraft." Carl nods. "It will be ready." Vogel studies the Mustang. Its silver skin, now marked with German crosses hastily painted over American stars, represents knowledge gained at cost. "How many of these do the Americans have?" "Intelligence estimates over 5,000 P-51s produced by the end of 1944, Herr General. Current production continues at approximately 300 per month." Vogel's expression hardens. "And we build how many Bf-109s monthly?" "Approximately 200, sir, but that number declines as factories are bombed." The mathematics require no elaboration. Vogel turns and walks toward his office. In the hangar, the Mustang waits, silent and silver. The following morning, 16th April 1945, Hans returns to the flight line. The Mustang sits in the same position, but the engine cowling now shows signs of recent maintenance. Fresh safety wire gleams at panel edges. Carl approaches with a clipboard. "The fuel system has been completely serviced," Carl reports. "New filter installed. Carburetor cleaned and calibrated. I performed a ground run yesterday afternoon. No anomalies observed." Hans accepts the clipboard, reviews the maintenance log. The entries are thorough, detailed. Carl's work is meticulous despite the challenges. "You believe it will perform normally?" "Based on available data, yes. But flight testing is the only true verification." Hans nods. "Then let us verify." The pre-flight proceeds smoothly. Hans performs the external inspection, checking control surfaces, landing gear, propeller blades. Everything appears secure. He climbs into the cockpit, straps in, completes the checklist. Engine start at 0750. The Merlin catches immediately, settling into a smooth idle. Hans monitors the instruments closely. Oil pressure climbs into the green. Fuel flow is steady. No indication of the previous day's problems. He taxis to the runway, performs the run-up. Magneto check. Both mags produce smooth operation. propeller cycle, pitch change occurs normally, engine instruments, all parameters within range. Tower clears him for takeoff at 0800. Hans advances the throttle. The Mustang accelerates down the runway, its tail lifting at 40 miles per hour. At 75 miles per hour, Hans eases back on the stick. The Mustang rotates smoothly and climbs away from the concrete. The engine runs perfectly. No misfiring, no power fluctuation. Just smooth, powerful acceleration as the Mustang climbs through 2,000 feet. Hans levels at 5,000 feet and begins the evaluation sequence again. This time, the aircraft performs as designed. Control response is immediate. Engine power is constant. The fuel system delivers without interruption. Hans maneuvers through a series of aerobatic figures, testing the limits systematically. Roll rate, exceptional. Turning performance, competitive with the Bf-109 at high speed. Dive acceleration, impressive. Recovery from high-speed dive, smooth and controllable. The Mustang handles every maneuver with grace. Hans climbs to 10,000 feet. The engine shows no signs of strain. He cruises at 300 miles per hour, noting fuel consumption. The efficiency is remarkable, approximately 50 gallons per hour at cruise power. With a total fuel capacity of nearly 300 gallons, the range calculation confirms his previous estimate. This aircraft can reach any target in Europe. At 10,000 feet, Hans points the Mustang toward the Alps. The mountains rise ahead, their peaks white against blue sky. He maintains altitude and speed, watching the terrain scroll beneath him. This is the second test flight, but the first without mechanical compromise. The Mustang performs flawlessly. Every system operates within parameters. The Merlin engine produces steady power. The fuel system delivers consistent flow. The airframe responds to control inputs with precision. Hans considers what this means strategically. Allied bomber formations, previously vulnerable during deep penetration raids, now enjoy escort coverage throughout their missions. Luftwaffe interceptors must engage not just bombers but also fighters with superior range and high altitude performance. He banks the Mustang into a gentle turn, observing the ground below, villages, roads, forests, all German territory. But from this altitude, borders become abstract concepts. The Mustang's range erases geographical limitations. The radio crackles. Test pilot, you have 15 minutes remaining in assigned airspace. Acknowledged. Beginning return sequence. Hans turns back toward Bavaria. The flight has provided the data needed. The Mustang, when properly maintained and fueled, represents a significant advancement in fighter design. Its combination of range, performance, and handling creates a platform that changes air warfare fundamentals. He descends to 5,000 feet, maintaining cruise speed. The engine runs smoothly, its rhythm steady and reassuring. Below, the landscape transitions from alpine terrain to agricultural plains. The test facility appears on the horizon. Hans enters the traffic pattern at 2,000 feet. Landing checklist, gear down, 3 green lights. Flaps, partial extension, airspeed 90 miles per hour. The Mustang settles into the approach, stable and predictable. He crosses the runway threshold at 80 miles per hour, begins the flare. The main wheels touch concrete gently. Nose wheel follows. Hans deploys full flaps and applies brakes. The Mustang decelerates smoothly, tracking straight down the center line. He taxis to the hangar, shuts down the engine. Silence fills the cockpit as the propeller stops. Hans sits for a moment, processing the flight. The Mustang has revealed itself completely now. Its capabilities are exceptional. Its impact on the air war is undeniable. He climbs out onto the wing, then jumps to the ground. Carl approaches, concern evident in his expression. The engine performed perfectly, Hans reports. Your repairs were successful. Karl allows himself a brief smile. Good. General Vogel will want your report. Hans nods. He walks toward the debriefing room, knowing the report he writes today will carry different weight than yesterday's assessment. The second report takes less time to write. Hans documents the successful flight, noting the Mustang's performance across all parameters. No anomalies, no limitations discovered. The aircraft operates as designed. He includes specific observations. Control harmony remains excellent throughout the speed range. High-altitude performance exceeds German fighter capabilities above 25,000 feet. Range calculations confirm escort capability to any target within European theatre. Bubble canopy provides tactical advantage in visual scanning for threats. The recommendations section requires careful thought. Hans writes, the P-51D Mustang represents current Allied technological and industrial superiority in fighter aviation. Countering this advantage requires either matching its capabilities through new German designs or modifying tactical doctrine to avoid direct engagement. Both options appear problematic. German industry struggles to maintain current production levels under Allied bombing. Development of new fighter designs requires time and resources unavailable in April 1945. Tactical modifications might delay defeat but cannot prevent it. Hans completes the report at 1200 hours. He signs it, adds the date, and delivers it to General Vogel's office. The general reads through the document slowly, his expression unchanging. Your conclusions are clear, Vogel says finally. And accurate, I presume? Based on 2 flights in the aircraft, yes, Herr General, the P-51D is superior in its design role. And what do you recommend we do with this knowledge? Hans considers the question. The honest answer is uncomfortable. We acknowledge the capability gap and focus resources on areas where we retain advantage. Ground-based air defense, jet fighter development, pilot training quality. Vogel sets the report on his desk. Your assessment will be forwarded to higher command. I suspect it will confirm what they already know, but wish not to accept. Yes, Herr General. Dismissed, Richter. Hans salutes and departs. He walks across the airfield toward the barracks, passing the hangar where the Mustang sits. Mechanics continue their work, documenting every detail of its design. Knowledge acquisition continues even when strategic application becomes moot. In the hangar bay, sunlight illuminates the silver fighter. Its presence generates both admiration and resignation. The Mustang represents not just American engineering but American industrial depth. The capacity to produce thousands of advanced aircraft while German factories struggle to maintain output. Hans enters the barracks, changes from his flight suit, and lies on his bunk. Outside, the day continues. Aircraft engines sound in the distance. The war proceeds toward its inevitable conclusion. The Mustang remains in the hangar, studied but not understood, admired but not matched. 3 days after the test flights, 18th of April 1945, Hans receives new orders. He is reassigned to a fighter unit defending against Allied bomber raids. The Mustang test program concludes. The aircraft will remain at the facility for continued engineering analysis. Karl Schneider and his team continue their detailed examination. They photograph every component, measure every dimension, document every system. The data accumulates in binders and filing cabinets, knowledge preserved even as the war situation deteriorates. The Mustang undergoes complete disassembly, wings removed, engine extracted, fuselage sectioned for internal structure examination. Each piece provides insights into American design philosophy. The laminar flow wing construction reveals sophisticated aerodynamic understanding. The engine installation demonstrates efficient packaging. The fuel system layout shows careful attention to weight distribution and center of gravity. Management. By late April, the engineering team produces a comprehensive technical report. The document spans 200 pages, including detailed drawings, performance charts, and comparative analyses. Copies are distributed to remaining aircraft manufacturers and research facilities. The report concludes that duplicating the Mustang's capabilities would require approximately 18 months of development plus extensive testing. Production implementation would add another 12 months. The timeline extends far beyond Germany's remaining capacity to conduct such programs. On 28th of April 1945, Allied forces approached the test facility. Personnel receive evacuation orders. Karl supervises the destruction of sensitive documents and equipment. The Mustang, partially disassembled, cannot be moved. Engineers photograph its remains one final time, then disable it to prevent Allied recovery of German analysis data. Hans Richter, flying a Bf-109 from an airfield 50 kilometers east, receives word of the facility's abandonment. He thinks briefly of the Silver fighter he tested for less than 2 hours total. The experience provided clear evidence of Allied air superiority, knowledge that confirmed what operational results had already demonstrated. American forces occupy the test facility on 30th of April 1945. They discover the disassembled Mustang, its components scattered across the hangar floor. Intelligence officers photograph the scene, documenting German efforts to analyze captured equipment. The facility's technical reports are recovered partially burned. Enough survives to reveal the depth of German engineering assessment. Allied analysts note the thoroughness and accuracy of the evaluations. The reports confirm that German engineers understood exactly what they faced. The war in Europe ends 8 days later. The P-51D Mustang at the Bavarian test facility is eventually reassembled using replacement parts and returned to American service. Its brief time under German evaluation becomes a footnote in military aviation history, a moment when technical excellence was recognized across battle lines.